In this video, I'll show how to build turnouts from scratch. I'm building turnouts in N-scale using Code 40 Rail, but the techniques should work for other scales and rail sizes as well. I used the printout templates from the Fastracks website. I cut out the turnout I want to build from the paper sheet and glue the template directly onto the road bed with white glue. I try to use as little of the glue as possible to keep the paper from becoming too wet and wrinkling up. I don't put glue where the throw bar will go, because I will remove the paper from that area to avoid the throw bar sticking to the paper too much when everything gets soaked in glue during ballasting. If you just want to practice building turnouts, you can simply build them on the piece of paper and transfer them to the layout later if you're happy with the result. Since I don't own any jigs to build the point and frogs, I'm using a Dremel tool with a snake extension and a silicon carbide grinding bit. This one is quite worn already, but it'll do. Grinding the rail into the proper shape sends debris and metal shavings flying in every direction, so safety glasses are very important. When the glue under the template has dried, I drill a 10mm hole where the throw bar will go, so it is only supported by the road bed at the ends in order to minimize the friction that the turnout mechanism has to overcome. Then I remove the paper at the throw bar location and start to cut the PCB and wood ties to length and glue them into position as indicated on the template. I usually add 1 or 2 PCB ties between the frog and the points, so I have more options to tune the track as needed. After the PCB ties are in place, I create cuts in the copper layer with a small milling bit on my Dremel tool to isolate the frog from the rest of the turnout and to isolate the point rails from each other. The locations for the cuts are indicated on the Fastracks template. I test the PCB ties with a digital multimeter to make sure that everything is cut properly, so I don't need to chase down mystery shorts later. I also like to fill the gaps with UV cured glue to hide them in the finished turnout. When I'm done preparing the ties, I let the glue cure for at least an hour before sanding the ties flush with each other. Now is also a good time to drill a hole into the road bed for the feeder wire to the frog, so the feeder can be soldered while the frog is being built. I like to build my turnouts starting from the straight stock rail and then working my way over to the curved stock rail. That way I can build each part to fit the pieces already in place. If you build both stock rails first, then the frog needs to be at the correct position and the exact angle to accommodate both stock rails at the same time, and this is very hard to do. By building the frog after the first stock rail, you have more wiggle room to adjust the second stock rail as needed. Before starting filing the stock rail to the correct shape, I hold the piece of rail I want to use against the printer template and mark the start and end of the section I need to work on with a Sharpie. Then I use a small triangular file and file a notch into the rail foot at those positions before I start grinding away the rail foot between these two notches. In order to grind the rail to the required shape, I put the Dremel into the lowest setting and lightly push the rail against the grinding bit with my finger. I typically do short passes and then inspect the result so the rail never gets particularly hot. While working on the stock rail, it's important to try to not mar the rail head. The stock rail needs to accommodate the point rails but should still provide a smooth surface for the train wheels to run on. Filing something like a notch into the railhead only provides an opportunity for the wheels to catch and derail. Ideally, the web stays untouched as well, but this is difficult to achieve. It's better to take away a little bit of material so that the webbing recedes a bit from the point rail rather than the other way around, so the point rails can properly settle against the stock rail. For the same reason, it's important to remove the rail foot entirely on the inside of the stock rail. I judge whether or not to keep taking material off the rail based on the reflection on the rail and by testing if my fingernails catch on anything at the foot. When I'm happy with the shape of the stock rail, I start soldering it to the PCB ties using the rail position on the printed template as a guide. I try to solder the rail as straight as possible, so I don't need to make too many adjustments on the following parts of the turnout. When the first stock rail is in place, I start working on the frog. This requires 2 pieces of rail to be shaped and then soldered together. I always try to file these 2 pieces as sharp as possible. If the angle turns out too shallow, it's always possible to simply fill the gap with solder. I start soldering the frog by soldering the first piece of rail into the correct position. Then I double check the track gauge with the NMRA gauge. After this, I place the second piece of rail at the correct angle as indicated on the template and line up the tips of both pieces with each other. Then I solder the other end of the rail to the PCB ties to keep the rail in the right place. Then I use a locking tweezer to clamp both pieces together and place the tip of the frog at the correct position. I use the NMRA gauge to make sure that the tip of the frog is still at the correct distance from the stock rail. When I'm happy with the position, I heat up the rail and the tie and then add solder until the solder starts to flow over. I let the joint cool and remove the locking tweezers. Then I check the gauge once more and inspect the frog to make sure that there is no gap between the rails where the wheels might catch and derail. If I need to make adjustments, I put the tweezers back in and resolder the frog until I'm happy with the result. After the frog has been finished, it's time to work on the point rails. The point rails need work on both ends, so it's important to get the length right. I place a piece of rail on the template, matching the end of the rail where the wing rail ends, and mark the top of the rail where the bend between the point rail and the wing rail is located with a Sharpie. Then I file a notch into the rail foot at the marked position on both sides and bend the rail to the correct angle. After placing the rail back into position and lining it up with a printed point rail, I mark the top of the rail until which it needs to be filed to shape. Much like with the stock rails, the rail foot needs to be removed from the point rail so it can settle against the stock rail properly. It's also better to remove a little bit more on the bottom of the rail, but it's really important to leave enough material to get a good solder joint to the throw bar later. In addition to the modifications on the rail foot, the rail head needs to be filed away on the side facing the stock rail. Filing the rail head on the side facing away from the stock rail is also necessary, but only in a small area close to the end of the rail. Doing so will result in the head of the rail dropping down under the level of the rail head on the stock rail, helping the wheels to go in the right direction. When I'm happy with the shape of the point, I grind the wing rail end at a 45-degree angle horizontally and vertically to guide the wheels. The shaped part should be about 1 tire width long. Then it's time to solder the point rail in place. The point rail needs to be placed such that the flange clearance against the frog rail is correct and the rails on either side of the gap line up with each other. Using the 3-point gauges helps keeping the rail in place while checking the position. I solder the point rail in one location and then check the position before making the next solder joint and keep checking flange clearances at the frog and the track gauge against the stock rail until I have finished all solder joints. Sometimes the frog desolders during this step. It's best to wait fixing this until the second point rail is in place. Building the curved point rail is a bit more tricky since it's curved, but really just consists of repeating the steps from the straight point rail. I pre-bend the curved point rail so I don't need to deal with the tension in the rail while soldering. It takes a bit of practice to build the point rails so that the wing rails end up being the same length, but it's best to focus on flange clearance and rail alignment since those affect the function of the turnout, while the wing rail length is mostly a cosmetic issue. While soldering the wing rails, I constantly check the flange clearance between the wing rails and the frog and also check the flange clearance in relation to the stock rail to make sure that the wheels cannot bind when passing the frog. I also solder the rail around the frog area from the outside to avoid excess solder being stuck in the space between the rails where it's hard to remove. This part of the build process is the most important since it's difficult to fix after the fact. When working on the wing rails, right next to the frog, I place tweezers onto the frog to act as a heat sink to avoid destroying the frog solder joint. If the frog got desoldered during the point rail installation, you can now squeeze the frog rails together again with locking tweezers and reheat the frog to fix the solder joint. When the frog has cooled down again and no further corrections are needed, I file the rails in the frog area flush with each other. Doing so also removes any excess solder from the rail head. The last major step is the installation of the second stock rail. Shaping the rail works just the same way as for the first stock rail. Before soldering the curved stock rail, I pre-bend it to roughly the right curvature so there isn't any tension in the rail. When soldering the rail in place, it's important to maintain the correct gauge against the frog and the curved point rail. When the second stock rail is in place and my test car rolls through the frog area without complications, it's time to build the check rails. While Fastrac seems to suggest bending the ends of the check rails at an angle, I like to simply grind them at a 45-degree angle, just like I did with the wing rails, before soldering them in place, maintaining the correct flange clearance. When the check rails are in place, I do a little test run. While doing this, I check if the car binds in the frog area and also if it's possible to force the car into the wrong branch of the turnout by applying a little side pressure to the car. The last missing part for a functioning turnout is the throw bar. I use a regular PCB cross tie from Fastrac for this. I make sure that it slides easily underneath the tracks first. If it seems to bind, I file the copper cladding until the tie fits underneath the rail. I also drill a 0.8mm hole into it for a steel wire to actuate the turnout. Soldering the points to the throw bar is a bit tricky. The throw bar needs to remain straight so it doesn't bind against the ties next to it. The solder joint requires enough solder to properly grab the point rails, but not so much that the excess solder interferes with the movement of the throw bar underneath the stock rails. If in doubt, it's better to err on the side of caution and use too little solder. Even if the joint breaks later on, it's a lot easier to go back and add more solder while repairing than try to get rid of excess solder. After that, I grab the point rail and hold it in the correct position when reheating the solder joint and letting the point rail settle in the correct position. When both point rails are soldered to the throw bar, I check the point spacing with the NMRA gauge and make adjustments as necessary. The final step is cutting the rails around the frog to isolate it from the rails leading into the turnout. Sometimes the solder joint breaks while doing this, but this is easy to fix by realigning the rails and heating up the solder. So this is how I built my turnouts. It takes about 3 hours to build one turnout, so it's a rather time-consuming process, but it does save the money for jigs and allows me to build the turnout to fit exactly into the space and avoid unnecessary rail joints. I hope this tutorial was helpful to you. If you have any questions, let me know in the comments.